So it looks like a lot of us have answers, and Nate's got a couple different strategies to find his answer. Okay. All right, let's get some answers, and then we'll go back and justify. Okay, Nate, what do you think it is?
2 6. However, I also did it another way by solving it by turning the numbers into decimals and solving it like a decimal.
Did you get the same answer? What'd you get?
I did 1, 2, wait, 1 half. 1 and 2 tenths and 1 and 4 tenths. And I got 2 and 6 tenths.
So you got 2 and 6/10 like that?
Yeah.
Okay. So remember, if you agree, you're going to give me this. You're going to say, I agree with Nate. Right? Evan, what do you think the answer
I thought you didn't add the denominator.
is? Okay, so what do you think the answer is?
Oh, I was just going to say 2 4.
You think it's 2/4? Okay.
Yeah, I didn't say. Yeah.
Okay. So Evan thinks it's 2/4. What do you think?
3/4.
Okay. Ooh, lots of hands went down with that one.
No, it's
Fee?
3/4.
Hang tight for 1 second. So
I
did
think-
I
I
see
think
a lot
it's-
of people agree with 3/4?
Yeah.
Can I say something? A lot of people agree. I'm not calling on anybody who's calling out. So I'm looking for a raised hand. So we have 2 6, 2/4, and 3/4. Nate, do you mind if we hold off on that decimal for right now and just focus on the fractions? Is that okay?
Oh, it's 2
Okay.
4s.
So we have 2 6, 2/4, and 3/4 as our responses. Okay? Now we are going to switch over and you're going to justify which one you think is the answer. So you're going to talk it through and I'm going to record what you said. Okay? So Fee, you have one that you feel strongly about. Which one is it? All right, Fee thinks the answer is 3/4 and she's going to tell us why. Oh, I see a lot of this.
Yeah, but
So
how?
I see a lot of agreement. So what we're going to do right now is listen, and Fee's going to explain it, and maybe you'll see after she explains it. All right, you ready?
Yeah, you have
Okay.
to find a common denominator, so
Okay.
the common denominator would be 4.
Okay.
So
So what does that mean? A common denominator. Tell me what that means. It's a lot of math words. What's a denominator, first of all?
the bottom.
Which means what? The what? You
The
said
whole
it?
part.
The whole. Good. All right. So the denominator representing the whole. You said common. What does that mean?
What?
Like one that can go into one.
So you want to make them the same, right? Yeah. Okay. So Fee said we kind of talked through a bit the other week. We actually. I'm gonna pull these out and remind you. We actually did this. So we said here was our 1/4, or sorry, our 1/2 and our 1/4. Right? So there's 1/2 plus 1/4. And here's 2 6.
What?
Yeah, no.
Doesn't work, does it?
Yeah, that ain't happening.
Doesn't work.
Sorry.
Okay? So that gave us our first clue that we can't just add.
Oh, no, the answer is.
Okay, so hang tight, because Fee's going to go
getting
back to
there.
explain it. All right. So Fee, you said we didn't call it a common denominator last week. What were we saying? We were changing out the pieces, right? To make the denominators the same. So tell me, keep going, and I'm gonna maybe stop. I
2
can lost my
goes
thing.
into 4, so you would times 2 times 1. And
Okay.
It's 2. So then 2/4.
So you think that 1/2 is equivalent to 2/4. Is that right? Okay, those are equivalent fractions?
Yeah.
Okay.
And
Then what?
you would just do plus 1/4 and you get 3/4.
Okay. A lot of this happening. How many people thought the same thing? Me. Okay. Let's check it with our pieces. Let's do it with our pieces. So you two were the ones who were telling me you weren't sure. So I need you to be here with me and not playing with the fuzz. Okay? All right, so Fee, how come, scoot forward just a tiny bit. I want you to go back to telling me why you changed 1/2 into 4ths.
Because 2 goes into 4 and 2 times 2 is 4.
Okay, so Jeremy, you with us? Could I trade out, could I change my 4ths into halves?
No.
Okay, that's not going to be very easy, but Fee said, I know that 2/4 is equivalent to 1/2. So instead of my 1/2, I now have 2/4 plus 1/4 equals 3/4.
That's
Does that make sense? Is that what you did? You did it in your head. Excellent. So you were close, right? So you were on the right track. It seems like maybe you just forgot to add that last fourth, right? So you got to that equivalent fractions piece. Okay? So when we are adding fractions, one of the ways to do that is what Fee said, which is find a
Common denominator.
And the way that we find a common denominator is by using, Anna, are you with me?
What?
I didn't think so. Equivalent fractions. Remember that very first day when you guys laid out the pieces and you figured out which fractions were equivalent to each other? This is going to take us back to that. Okay? Is there another way to find equivalent fractions?
Yes.
Yep, and we'll get to that. We will get to that. Okay? But for right now, this is where we're going to kind of go. Okay? Equivalent fractions is going to help us find that denominator that we can add together to make it correct. So just going back to that, what we had, we cannot say that 1/2 plus 1/4 is 2/6, right? Does that make sense to everyone? Just want to make sure we're all on the same page. We've proven that that doesn't work.
Wait, so what
Okay.
did Fee do? She did 2 times 1 and then is 2.
So she created an equivalent fraction, right? So she said, I can change out my halves into fourths, right?
Okay.
Okay? She did it a little bit different way that we're going to get to. All you need to know right now is we use that equivalent fraction. Okay? We're going to make a chart of equivalent fractions so that we can hang it up when you guys did that work, and we're going to add to it. Anna, I don't feel like you're with me when you're writing when I'm talking. Thanks. All right. Jeremy, anything you want to add or say?
You can actually make halves go into any even fraction.
So you think you can change halves into any fraction that has an even denominator? Is that what you mean?
Yes.
Is that what you found when you did your equivalent fractions? So what you're saying, I could change halves into fourths, I could change halves into sixths, I could change halves into eighths, tenths, and twelfths. Does everybody agree with that?
Yes.
Interesting.
Jeremy, we don't have 24 on the board.
But we could have 24ths is what he's saying, right? So 1/2 would be how many 24ths, do you think?
212.
24. Wait, 12, 24.
12 24ths? Okay. So we could change it into 24ths, right? Okay.
100.
We could keep going. We're not going to, but we could.